So the next operation that we are going to see is display function. Now again, this is one of the operations on stack. We have already seen push and pop methods. This particular method is talking about displaying the elements from the stack. Again, very simple. Let's try to understand how this code is executed and how the concept works. So here, when I want to display the elements, I want to travel through my stack and I want to display each element that are there in my stack. So let's try to understand this concept. Suppose this is my stack, 10, 20, 30, 40, 0, 1, 2, 3. Right? And the name of my stack is stacked. Again, the same variable that I'm trying to use in the code. Fine. Now for me to display the elements in my stack, which condition am I supposed to check? That whether my stack is empty. Why not full? Because if stack is full, obviously I would want to see what elements are there. But here in this case, I would check the condition that is my stack empty. So if my stack is empty, I would just return that my stack is empty. Printf stack empty. Right? So this is the condition if statement which talks about is empty. So it is common sense for us to understand that if there are no elements in the stack, there's nothing to display. So that is the condition I'll check. It means. Second is my else statement. This is the actual code for display. What am I doing over here? You see a printf statement which talks about displaying elements. Okay. And then I take a for loop. We already know that when we want to travel through elements and display all the elements in a particular data structure, we have for loop to execute. And that for loop will help us to travel each element. Okay. Now let's see how this for loop is executed. We know that stack follows LIFO. That means every time you are trying to insert the element, there is something which is pointing to the last element, and that is my top. That top is always going to point to the last element. And whenever I want to delete elements or whenever I want to display elements, I have to start from this particular element, not from below. So here what I'm trying to do is for I is equal to top, that is my first element is talking about this particular element, 40. So for my I is equal to top, I is greater than 0. I need to travel through that particular stack till my I represents 0. I equal to 0. I greater than equal to 0. Because when the condition, this condition goes false, I obviously know that there are no elements below 0. Okay, so I need to check condition till where I is greater than 0. I am traversing reverse. And then what do I say? I minus minus. So when I say I minus minus, that means I am trying to display this element first, then the second, then the third, then the fourth. Stack concept talks about LIFO, that is last in first out. So my display should also be in that format. My output should look something like this: 40, 30, 20 and 10, and not the other way around. It should not be 10, 20, 30, 40, because for stack the concept that we use is LIFO. So the last item or the last element that is there would be the first one to be displayed. So 40, 30, 20, 10. So that is my for loop, right? And then I am just printing the elements as and when I'm traveling through that particular for loop. We already know how a for loop is traveled. For I is equal to top. So this is initialization. After initialization, it checks the condition. After checking the condition, it will perform what is there inside that for loop. After this, what happens? There is increment or decrement. This decrement here happens till when? Till I reach the end of the stack. And I know that my end would be 0. Because after 0, anything after 0 is minus 1 would be no elements. It is an empty stack. So that is what I am printing.